All right, everybody. Welcome back. Hope you had a fantastic break. Happy New Year. 2020 is behind us. The future is what we make of it. Let's try to make the best out of 2021. The best way I can think to try and get started this year is start pushing our mind into a new direction, learning some new ideas. We're going to be taking a look at stuff called polygons. Let's make sure we understand what a polygon is before we get going. All right. As you can see, I already on the beginning of the year, I had trouble writing. Polygon is a closed figure with segments. Remember, segments are straight objects, so our sides need to be straight segments that are joined at their endpoints. Those segments can't necessarily overlap. So we need to close in space. And a lot of you have some prior knowledge of what we call each of these objects. You need to know these names. This will be part of your tests. So most of you guys are pretty good at the three sides. Let's try and get this list going as fast as we can. Three sides. Triangle. Four sides. Usually I'll have some kids start yelling out words like square, rectangle, rhombus. Those are four-sided figures, but those are very special four-sided figures. If there's nothing special about the object except that it has four sides, that's called a quadrilateral. Five sides. Pentagon. I challenge you to try and say it out loud before I get to it. Six sides. Hexagon. Most people don't know seven sides. There's two kind of acceptable names. Some people call it a septagon. I prefer the name heptagon. We see a lot of eight-sided figures out there. Hopefully when you're stopping in your car, those are all octagons. Nine-sided figure, nonagon. 10-sided figure, decagon. And if we got all the way up to 22 sides, I wouldn't need you to know the actual verbiage. There is, you can look it up on the internet. They all have names based on some sort of Latin prefixes, but 22, you might actually see we might be talking about a 22gon. If you saw that, I'd want you to understand we're talking about a 22-sided figure. And we want to be able to have those discussions, all right, but without having to memorize all of the specific names. So be ready to adapt if you see a number -gon. We're just talking about that many sides. All right. So each of these objects, you'll need to be able to figure out what is the sum, this means adding everything up, of the interior angles on the inside. So if we talked about the most basic shape here, triangle, three sides. We've covered this in the past. The three angles inside must add up to 180 degrees. Let's go with green. Now, if we were to take that object and if we have 3 points, we have three sides. If I add another point, then my object goes from three sides to four sides. So we see we got 1, 2, 3, 4 sides on the outside, but that's composed of two triangles. Since I know I have 180 degrees inside of this triangle and 180 degrees inside of that triangle, now we should have double 180 degrees, which is 360 degrees. We can continue to play this game if I add another side, 1, 2, 3, 4, 5. If I have five sides, it's composed of three triangles. Three triangles times 180 degrees, 540. So every time we move this on, we're going to gain an extra triangle. But please understand, if on the test I ask you what is the sum of the interior angles of an 8-sided figure, or even if I went to 22-sided, you don't want to try and create this table. But if you try and see the pattern that exists here, this number continues to go up by 1. Same thing over here as these numbers go up by 1. But realize if I have 6 sides, that's 4 triangles. 5 sides has 3. So the relationship, there's always 2 less triangles. So this would lead to a fantastic formula. If I want to find the sum of the interior angles, all I need to do, I'll have the number of triangles, which is 2 less than the number of sides. So if I got to 22, I would want to do 22 take away 2. That would tell me how many triangles there are, times 180 degrees, which is the amount of degrees in each triangle. 22 minus 2 is 20. Times 180, we have 3,600 degrees inside of this shape. So the formula we just used, take the number of sides, n, minus 2, times 180. This will work every day of the week and twice on Sunday, and you'll be able to create this list. You don't have to make the whole list. But whatever amount of sides I give you, you can find the sum of the interior angles. All right? So if we're talking about interior angles, we also have a discussion talking about exterior angles. So if we look at a basic shape here I've got 1, 2, 3, 4. This is a 5-sided figure. What we're looking at is a pentagon right now. There's 5 sides. There's 5 angles on the inside. The question is, where's the angles on the outside? Somebody might say, well, if there's 5 on the inside, there's got to be 5 on the outside. Your instincts would actually be correct. Problem is we can't see them right now. In order to see an exterior angle, you'd have to choose a side. Let's say I'm going to choose this side here, and you'd have to extend it in one direction. If I extend it in one direction, I now have an exterior angle. Here's one of the 5 exterior angles. Now realize that exterior angle forms a linear pair with one of the interior angles. This will always be the case. So if I go to the next side, I extend it out. Here is a second exterior angle. So here we got 1, we got 2. I keep extending one of the sides in one direction, kind of making like a pinwheel. Here's the 3rd exterior angle. Here's the 4th exterior angle. And here's the 5th. All right. Now, the best part about these exterior angles is there's no crazy formula like we just saw here before. All right. The sum of the exterior angles, it doesn't matter which shape you're talking about. The sum of the exterior angles will be 360 degrees every single time. 360 degrees, even for 22 sides. You don't need a formula. You just need to remember that the sum of the exterior angles are always going to be 360 degrees. All right? And it's very helpful to remember that you have that linear pair that exists in between an interior and its exterior angle that it's adjacent with there. All right? So it's a big table. Hopefully it kind of makes sense. But along with this table, we have some important vocabulary. Okay? We need to know about these kinds of shapes. A concave shape. Hopefully you're kind of seeing these 2 words and you're making a connection, hopefully, that you've heard in the past to your science class. A concave figure. I'm going to give you the definition, see if we can try and figure out what this means. All right. A concave figure would be a polygon where 2 of the vertices can be connected with a segment, spell it right, that exists outside of the polygon. So what that means, if I start to draw a shape, let's go with, I did a pentagon before. Let's go with another pentagon. Here's one side. Here's 2. Here's 3. If I come inside, kind of cave in the object on side 4 and 5 here, all right, this object's now caved in on itself. And if I connect this vertex here to this vertex, this segment is not outside of the shape. But if I can do it with any of the vertices, if I connect those 2 vertices, all right, and understand that these segments that connect vertices that are not next to each other, because if the vertices are next to each other, we call that a side. If the vertices are not next to each other, we call that a diagonal. Since one of the diagonals can exist outside of the shape, because remember the inside was here, this is what we call a concave polygon. So I can do a big wordy definition for convex, but if you can't do this, then it's convex. Convex is just not concave. All right, if I can't create a diagonal or connect 2 vertices with a segment that exists outside of the shape, then it's convex. So every object has to be one of these 2 descriptive terms. All right. Now, a regular polygon, normally we think regular means nothing special, nothing much going on. In geometry, it actually means almost the exact opposite. A regular polygon is one that is both, has to be both equiangular and equilateral. So let's look at a hexagon here. If I draw you a hexagon here, I'm going to draw you some information. If I knew this angle was the same as this one, which is the same as this one, and this one, and this one, and this one. And what if I knew this about the sides? The question is, what is the best description of this shape? All right, some words that we would want to exist on there would be, well, first off, it's got 6 sides. One descriptive term would be, this is a hexagon. Now we have to try and say, is it convex or concave? Can I connect any of the vertices with a diagonal that exists outside of the shape? I can't, so it's not concave, it's convex. And lastly, is it regular? Well, I do have all of the angles that are the same, so it's equiangular. I have a mark on all of the sides, but not all the marks are the same. Since they're not the same, that's trying to say that this side is different from this. That means we do not have an equilateral shape, but I can put down a descriptive word of, it is equiangular. But I would need both of these terms to exist in order to use the word regular. All right. So this is a lot of information on day 1. I agree. But again, if you got here towards the end, it's a great time we should have that kind of information. If you're writing and taking notes along the way, you have access to this information all along the way. This is more fantastic information. And if you guys are taking responsibility for having access to this information, that is quite possibly how you're going to try and make the best out of the year 2021. All right. I hope everybody is back, rested up, safe, healthy, and ready to learn. You guys have a great day.